Today, I'm going to talk to you a little bit about managing an Azure application stack at scale. This is something that's not even necessarily Azure specific, but in the particular use case that we're highlighting here, we had a customer with an interest in using our service maps. So in OpsRamp, as you may or may not be familiar, we have service maps in our platform so that you can identify impacts that technology infrastructure has on your business applications. And using that capability, you can see, for instance, what is the availability of an overall application service over time. You can generate alerts that point back to the application service based on the failure or degradation of components beneath it, and also provide a very compelling view of what the current state of that application is. So one thing that's interesting about this, though, is generally you have to manually define this structure. So I have an example where we've identified a particular customer. So they may have application servers, they may have, some kind of cache servers like Redis. There's obviously going to be network connectivity involved. There could be database infrastructure, maybe a message bus like Kafka or MQ. And of course, everything ties into web servers. And, this could be built out to a greater degree of complexity. But the bottom line is very often in an enterprise environment or in an MSP environment, it's very likely that there's commonality among the different kinds of components that compose an application or a business service stack, right? It's likely that you're always going to have, a web server in the mix somewhere, a database in the mix somewhere, application servers in the mix, and maybe the other pieces could or could not be included depending on the particular application. But there's usually some commonality that you can leverage there. Why is this important? Because when we do things at scale, we are very interested in automating as much as possible. So in OpsRamp, we have a very robust REST API that lets you automate things like, for example, onboarding a large number of Azure subscriptions or AWS accounts that may have your applications running on them. We also have REST APIs for doing on-prem discovery initiation and things like that. But in this case, we were looking at a scenario where a customer had a very large number of Azure accounts. And within those Azure accounts, they would have customer-facing application stacks that were based on, for the most part, a fairly common paradigm of particular pieces that made up the application. So depending on how consistent your application stacks are across different applications, this might be more or less helpful, but there's almost always some level of commonality where this can be helpful. I'll also point out that in addition to working with our REST API in the raw, which you can certainly do and is pretty easy to do if you're comfortable with REST APIs, we also have an OpsRamp command line utility, OpsRamp CLI, which is available with a very, very simple Python installation. We just use Python package management, and you can just do pip install OpsRamp CLI, and voila, you get this really helpful CLI that lets you do a lot of these things that you might otherwise do with the API. So depending on if you're more comfortable with CLI or API directly, you can take advantage of that. So in this case, we used our CLI to onboard about 150 Azure accounts in bulk very quickly, much more quickly, obviously, than a human. Entering this information in a UI would ever be able to do it. And as we onboard those accounts into the system, those Azure subscriptions into the system, we discover all of the cloud native objects, whether those be virtual machines, load balancers, storage accounts, all that stuff that's in there that may be playing a role in being part of the application composition. So the next piece is that as we bring those assets into our inventory and into our topology in OpsRamp, we are leveraging a very important element that pretty much all cloud providers give you, which is the ability to tag your cloud objects, right? So when we do the discovery, we're providing that immediate visibility of the inventory. We get the topology of what cloud resources are associated with other cloud resources, whether that's AWS or whether that's Azure. We do that. And very importantly, if you have applied tagging in your cloud environment, we automatically ingest those tag definitions from your cloud environment, and we automatically populate them into our inventory as what's called custom attributes. And custom attributes are just that. They're basically additional fields that we bring in to a resource like a VM or an AWS, an EC2 instance, but it could be any other cloud native object. And we'll automatically populate our custom attributes, names and values, using the names and values that you have used in your cloud tagging. This is super helpful because now across our entire product in all kinds of different places, we can filter and search and slice and dice on your discovered infrastructure resources based on those same tags that you have applied in your cloud environment natively. And whenever we do a rediscovery scan, we'll get whatever updates that you have made on those tags. And we can also receive asynchronous notifications via things like AWS CloudTrail to automatically update them on the fly, maybe in the middle of the day, right? We don't want to wait for the next discovery scan that's happening later that night. We want to get immediate synchronization of that information. So we have the ability to do that as well. So we put the pieces together now. We have service maps, and we would like to be able to leverage our tagging in order to kind of dynamically build out many service maps based on some consistency and some convention in how our applications are composed and how we're tagging our resources in the cloud. And this is where it becomes important to understand and hopefully implement in your environment some concept of a consistent cloud tagging scheme, right? Because ultimately what you want to be able to do is use that cloud tagging information to identify things like what application is this resource for? What business unit is it associated with? Is there an external facing customer or customer ID that I can tie it to? If it's part of an application, which it probably is, what role is it playing in that application? Is it an app server? Is it a database? Is it a web server? Is it some kind of cache server? And in addition to that, is it part of the production environment, right? You've got a full estate that includes dev, test, prod, maybe additional environments. And if you're looking at a service map that's going to light up red, you want to know that if I'm going to jump when that service map lights up, that it's because it's something that's actually in production that I'm going to care about more than I would something from dev or test. So we can't do this for you. This is something obviously that you would have to adopt a standard in your cloud environment, or at least a subset of your cloud environment, to use a consistent set of tags and a consistent set of values to represent this information to whatever extent it makes sense for you. Now, why would we go and do that, and how does that help us with the service map? Well, when we're defining a service map, we have the ability to not just statically assign things to these different services, these different boxes in the service map. We have the ability to use these different custom attributes and dynamically filter based on criteria that we specify for these custom attributes. And you'll recall these custom attributes that are in OpsRamp, when it comes to your cloud resources, we've auto-populated them with your cloud tags. So if you have your cloud tagging scheme sorted out in a standard convention that we can make use of, we can leverage that to basically define a template service map, which is what we're doing here. And then we can make clones of that service map template, just doing replacement of, in this case, just the customer ID, right? So in this case, I've defined a service in a service map, and I've also used it in the name of the service map in the very top. And in the template, I've just called it my customer ID. But then when I clone it, I can replace that string, my customer ID, everywhere that I see it in the definition of that service map. So it'll change here at the top level, which is also the overall name of the service map, but it'll also change it wherever it sees it in things like these filter definitions, so that when I clone this and do the replacement across all of my different customer IDs that exist in my environment, in this case, right? I might have customer ID A, customer ID B. I would have new service maps that are basically a copy of this, except it would be customer A filtered for customer ID A and customer B filtered for customer ID B for the app role of app server and the environment of prod being the definition of this app server's service. And of course, we do the same thing across the board for all these other services. And because we're doing a dynamic rule-based definition here, when we clone it and make that tweak, it'll pick up the right resources. So next is, how do we do that cloning? Well, one of the features that we implemented in our CLI, and again, you can absolutely do this directly with our API. It's actually pretty easy to do, but for those who either don't want to deal directly with the API, or they appreciate just having an easy feature to do this in a quicker way, we've implemented a command in the OpsRamp CLI called clone service maps. Now, not only does it clone, though, in addition to cloning a service map name that you give it, there's also an option in it to replace one or more strings with a string of your choice. So this is basically a pattern that we put in our template called my customer ID. And we're going to clone this template service map, and we're going to replace wherever we see my customer ID in the definition of that service map with this other string A123, which is an actual customer ID in this case. So you get the idea that we start with this template service map, we do the clone, and then we have produced from that template service map a standard service map for customer A123. Now, that could be customer A123, that could be application ID A123. The concept is the same. As long as you have that convention of doing that tagging based on the application or customer and the role and the environment, we can knock these things out. So we take that concept and now we rinse and repeat. And we go across and we say, okay, I'm going to do this clone and I'm going to make all these clones of this template service map called my template map. And with each clone, I'm just going to replace it with a different customer ID. And I'm going to rely on the fact that I've got that tagging convention in my cloud resources that is going to have the correct customer ID on those cloud resources in a tag value, and also the role and the environment. So we can clone this across all of your customers or apps, and instantly, instead of manually building a ton of service maps, which is very time consuming. And I can tell you just about every tool you've ever worked with, that I've ever worked with, that has the concept of service maps, it is a very manually intensive process. So a lot of times you don't get the value out of it that you would otherwise get, just because you don't want to spend the time, and then you have to worry about maintaining that many. The beauty of this is you've just spent some time getting your tagging convention squared away. You've taken a little time building literally one template service maps, and then you can blast away and suddenly have 10, 20, 100, 200 service maps utilizing those conventions that are going to accurately reflect the current state of all those applications or customers, which is really handy. Even more importantly, when it comes to maintaining this these service maps, whenever you may make a change, maybe you make a change to your standard application stack or some other convention. Now, instead of going back and modifying your 100, 150, 200 service maps individually, all you do is delete them all, make whatever changes you need in your template service map, and then blast this off again and do your cloning again. And you've instantly got all of these service maps with your latest standards nicely defined. So it works extremely well. I'll just show you very quickly how this works in a real environment. So here I've got an actual OpsRamp instance. I've created a template service map called business app, and then a placeholder value called app name. And app name is just the string that I'm going to replace when I do the clone with an actual application name. And if we look at the definition of what's inside this service map template, right, you'll see that it's a business app with the name of app name. And then in each of these services, I've got a definition that says the application is app name. The service is whatever service that box is representing. So in this case, I'm looking at the application server box. So the application service is app server. That's the role that these resources fulfill in that application. And I've also got application environment equals prod. So these would be the tag names that would be my convention in my cloud environment. If you're not using a cloud environment, you could just as easily use these names as manually defined custom attributes that are defined directly in OpsRamp. But in this case, since it's cloud-based, we're automatically consuming these values from your public cloud tagging. And so we're going to clone this, and it's going to change just this value. It's going to do a replacement of app name with whatever the actual app name is. And when we do that, the result should be that we've got a new clone of this service map with the new application that I'm interested in seeing. So I'm hopping into my CLI. I'm going to run my OpsRamp CLI command. And let me just break this down for you really quick, what it's doing. I'm running the OP CLI, which is the OpsRamp CLI utility. I'm running the command called clone service maps, which is what this does. I'm specifying an environment name, and what this is for is just providing the API credentials that the OpsRamp CLI is using for communicating with OpsRamp in this case. We could provide, things like the URL, key, and secret as explicit command line options. The utility will let you do that. But what it also lets you do that's really handy is just create a YAML file that has your environments and credentials stored in it, and then just reference those credentials by name. So that's what I'm doing here. It's just, simpler and more compact. And then I'm providing the name or a unique substring of the name of the service map that is my template that I want to clone. And then I'm specifying one or more replace criteria. In this case, I'm only doing one replacement. I'm replacing the string app name, all uppercase, with ERP system. So this is going to make a clone of that service map template with app name everywhere I see it in the definition replaced with ERP system. And this is the piece that if I was doing 100, I would just repeat this command 100 times with the different names of my different applications and chug those out. So just for illustrative purposes, I'm just going to do it the one time. And if I wanted to do multiple replacements, I could do that as well. You can repeat this replace option as many times as you want as in the command. So if I wanted to replace this string and then replace another string, I could have, replace A with B, or replace C with D, and so on and so forth. But this is all I'm going to do here, and I'm going to fire this off and let it do its thing. And you'll see what it's doing is it's pulling down the service map definition, including all of its sub-services, which are those boxes within it, and getting those definitions. And then it's re-importing those, but with the transformed name in it. So that's all done now. Pretty simple. And now I'm going to go back to the list of the all of the service maps. I'm just going to filter that so you just see the ones that are relevant to what we're talking about now. And you'll see here is the original one, the template, and here's the one that just got created now from my cloning. And you can see app name has been replaced with ERP system. It was just created when I ran this now. And when I drill down into it, you'll see not only was it changed in the name, but inside the definitions as well. So if I look at the definition of app server now, you'll see where it used to be looking for an application name of ERP system. Where it used to be looking for an application name of app name, which was just my placeholder, so obviously nothing matched. Now it's looking for this real application name, which is ERP system, to represent the definition of this box in the service map. And you'll see, because I previously had set up these tags, that it's actually matching to real servers that are in my environment. So now when there are alerts on those servers that are actually my application servers for this app, that will cause this service map to light up, right? And you can also see when I go out of edit mode and I just look at that service definition, when I click on the resource tab, you'll see those two resources have correctly attached to it. And it works the same way across the rest of the boxes. They're using the same sort of dynamic definition. And so using that approach, you can very, very quickly have a ton of new service maps representing a very, very large portion, maybe all of your application estate and your environment, just by using some simple dividing criteria that you set up in your cloud environment as tags. So this is why we call this managing an Azure application environment at scale, because at scale you don't want to do things manually. You want to do things in an automated way, and using conventions like that really helps you out when you want to automate things in bulk like that. Thanks, and have a great day.